Mr. Wright here, and welcome to this film in which my colleague Mr. Neer works his way through 17 Grade 9 IGCSE questions. Now, these questions have all been chosen because they focus on topics which we think are going to come up in Paper 2H. So make sure you get the very most out of this film. You can download the questions by clicking the link in the description and try to tackle the questions before you watch Mr. Neer work his own way through them. Or, of course, you can work alongside Mr. Neer, watching the film as you work. Either way, I'm quite sure you'll get an awful lot out of this film. Please do leave a comment, tell us how you've got on with the film, and of course, if you fancy thanking Mr. Neer for his efforts, then that would be appreciated too. Please do share the film with anyone else you know who's taking their IGCSE Maths and aiming for that top grade. Right, let's let Mr. Neer get on with the maths.
So this is a quite involved algebra question about a frustum of a cone and a sphere. So basically the question goes on to talk about the volumes of the solids. So we're going to be interested in the volume of this frustum of a cone, which is a cone that's had its top chopped off. So the volume of this is going to be equal to the volume of the big cone minus the volume of the cutaway cone. So the volume of the big cone is 1/3 times pi times its radius, which is k times r squared, times its height, which is kh. And that would give you the volume of the big cone. We're now going to subtract from that the volume of the small cone. So that's 1/3 times pi times its radius times its height. Now, I can tidy that up a little bit because this first one is 1/3 pi. Now, the k and the r are both squared, so that becomes k squared r squared times this k gives me k cubed r squared h minus 1/3 pi r squared h. Now, these two terms have a lot in common. They both have 1/3, they both have a pi, they both have an r squared, and they both have an h. So I can factorize that out. And in order to complete the first term, I just need a k cubed, and what I have taken outside the bracket is the final term, so I just need to multiply that by -1. And that is the volume of the frustum of the cone. Let's scroll down. So we now have the frustum of the cone. So the volume of shape A is going to be the frustum of the cone, which is 1/3 pi r squared h times k cubed minus 1, plus the volume of the hemisphere. And the volume of the hemisphere is 2/3 pi r cubed. And that's the volume of shape A. Now, the volume of shape B is the volume of the small cone. So that's the volume of shape A. So the volume of shape B is the area of the volume of the small cone, which is 1/3 pi r squared h, plus the hemisphere, which is 2/3 pi r cubed. 2/3 because the volume of a sphere is 4/3 pi r cubed. Now, we're told in this sentence here that the volume of A, which I've got written below in blue, is equal to 6 times the volume of B that I have written in green. And this gives me a long algebra equation. Now, what I'm trying to find here is an expression for H in terms of K and R. So what that actually means is I want to end up with H is equal to, and then K's and R's on the other side. So, first thing I'm going to do is I'm going to leave the left-hand side the same, and I am going to k cubed minus 1, and I'm going to multiply out that bracket on the other side. 6 times a third is 2, pi r squared h, 2/3 of 6 is 4, 4 pi r cubed. Now, I can simplify this because I can divide this through by pi. Cancel, 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 cancel. Because every term's got a pi in it, I can simplify it to this. I can then multiply everything by 3 and divide everything by r squared. So I'm going to multiply everything by 3. Why? Because I want to get rid of these fractions. And I'm going to divide everything by r squared. So I'm going to divide by r squared. I'm going to knock that down to 1. R squared is going to cancel, and I'm going to knock that down to r to the 1. And I'm going to multiply it by 3. So when I multiply it by 3, the third disappears, and I'm left with h times k cubed minus 1. I'm left with 2r. I'm left with 2h, and I'm left with 4r. And I've done something wrong. What have I done wrong? When I multiplied by 3, I multiplied these two left-hand terms by 3, and I need to multiply the right-hand terms by 3 as well. So when I multiply this by 3, this should give me a 6h, and the 4 should give me a 12r. Now, in effect, what I need to do is I need to make h the subject of this equation. So what I'm going to do is I'm going to collect every bit that's got an h in it on the left-hand side and everything that hasn't got an h in it on the right-hand side. And so the right-hand side will simplify to 10r. If I take the h out of this, I would get k cubed minus 1 minus 6. So this becomes h times k cubed minus 7 is equal to 10r. And so h is equal to 10r over k cubed minus 7. And that's the answer. But there's one nice little bit to look at as well. In the question, it said this: given that k is greater than the cube root of 7. Now, we haven't used that or paid any attention to that whatsoever, but the reason why that is there is because of this. If k cubed is greater than 7, then the bottom of this will be positive. So that happens when k is greater than the cube root of 7. If k was less than the cube root of 7, the bottom would be negative, and we'd have a problem because we'd have a negative height. So you didn't need to worry about that in the question, but that's why it was there. So the graph of g of x is transformed to the curve with equation minus g of x. So this minus sign is going to multiply all of the y coordinates by minus 1, which means if they're positive, they'll become negative, and if they're negative, they'll become positive. And so this represents a reflection in the x-axis. And you need to state both reflection and x-axis. Here we have the graph of y equals f of x, which looks like a parabola. Now, this 2 at the front here will stretch the graph from the x-axis by a scale factor of 2. So this point here with a height of 3 will get pulled up to here with a height of 6. This point here with a height of minus 3 will get pulled to here with a height of minus 6. 3 will go up to 6, and the points here at 0 and 0 will stay as they are. So this, with just the 2, would look something like this. So what I have drawn in a dotted line there is y equals 2 times f of x. Now, the minus 1 in here moves the graph 1 to the right. So this dotted graph that I have drawn moves 1 unit to the right. So it will end here. It will go through the axis here. Its minimum point will be here. It will go through the axis here. It will get to the top here. And then you need to draw this as accurately as you can as a nice smooth curve, which is going to look something like this. So we've got the graph of y equals sine x drawn from 0 to 360, and we're asked to draw the graph of 2 sine x plus 30. So firstly, in green, I'm going to draw the graph of y equals 2 sine x. Now the 2 at the front stretches the graph by a scale factor of 2 from the x-axis. So this point here gets moved up to here. This point will stay still, as will the origin. This point gets pulled down to -2, and in here this point gets pulled up to 1, this point here gets pulled up to 1, etc. So what I have is shown in green now is the graph of y equals 2 times the sine of x. Now the blue bit here, the plus 30, moves the graph 30 to the left. So this point that's at 90 is going to move across 1 square, which is 30 degrees to 60. This point will be where the graph starts from, 1 square to the left, 1 square to the left, 1 square to the left, and everything moves 1 square to the left. So in here, it would go from here to here, and then this moves 1 square across, and we need to pull in another little bit on the end here. So the graph is going to come down here. See how the blue graph is always 1 square to the left of the green graph, and there is your graph. Part B, if you complete the square, halve the coefficient of the x's, x minus 3 squared, minus the number you've just written down squared, plus 10, tidy it up, x minus 3 squared plus 1. So this is then a translation, and inside the bracket here, this minus 3 takes it 3 to the right, and this plus 1 on the end takes it 1 up. So this is a translation 3 to the right and 1 up. This is quite a demanding algebra question. So we have a cone and a sphere, and the radius of the cone and the radius of the sphere are the same, and we're told this sentence that k times the volume of the cone is the volume of the sphere. So I'm going to use that first of all. So k, if I rearrange this, is going to be equal to the volume of the sphere over the volume of the cone. Now the volume of a sphere is given on the formula sheet as 4/3 pi r cubed, and the volume of a cone is 1/3 pi r squared h. The pi's cancel, the r squareds cancel, the thirds cancel, and so you're left with k is equal to 4r over h. Or that h is equal to 4r over k, just rearranging that. Now we're asked to show that the total in bold surface area of the cone. So the total in bold is because it's saying it wants the curved surface area and the bottom of it, which is the circle. So the curved surface area has area of pi rl, and the base has pi r squared. Now I need to show that this can be written in this form here. Now, the important thing here is this expression in the box, it does not have any h's in it. It does not have any l's in it. It only has k's, an a that we need to find, and r. So, on the diagram here, we have a right-angled triangle that is the radius, the perpendicular height, and the slant height. So, these are linked by Pythagoras' theorem. So h squared plus r squared is equal to l squared. So L is going to be equal to h squared plus r squared square rooted. Now, I don't want any h's in my rule. So what I'm going to do is I'm going to pick up this, which is equal to h, and put it into here. So when I do that, I'm going to get the square root of 4r on k all squared plus r squared. Now, if I square that out, I'm going to get 16r squared on k squared plus r squared. Now, in order to combine these, I'm going to need a common denominator. So 16r squared on k squared, and so I'm going to make this have a denominator of k squared, which means I need to multiply the top by k squared as well. So this now is equal to 16r squared plus k squared r squared all over k squared. And the top has a common factor of r squared with 16 plus k. And the bottom is equal to k squared. And I need to square root all of those. Now, square rooting all of those is the same as, because they're multiplied and divided by each other, is the same as square rooting these individually. Now, that's nice because r squared square roots to r, and this k squared square roots to k. So this is my expression for L. So what I'm going to do now is, this is L, and I'm going to put L into here. So my rule for the total surface area is going to be pi r times L, which is r times 16 plus k, all over k, plus pi times r squared. Now, this is looking encouraging because this is close to what I have in here. Because in the first term, I have a pi, an r, and an r, a pi r squared. And in the second term, I have a pi and an r squared, which is what I want out the front of my bracket. So what I'm going to do is I'm going to take the pi r squared out. So I'm going to have pi r squared, and then I'm going to have the square root of 16 on k times k. That will complete the first term. And to complete the second term, I'm going to have 1, because pi r squared times 1 is pi r squared. Now, I need to get it into this form where it's a single fraction over k. So I'm going to turn that 1 on the end into k on k. So 1 is equal to k on k. And so I now get pi r squared times the square root of 16 plus k all on k. And give or take the order of what is set out above, I have the answer, and my answer is that a is equal to 16. We were trying to find this number in here, and this is a is equal to 16. Quite a demanding algebra question. So here we have two similar shapes, and we're told that the volume of statue B is 20% less than the volume of statue A, or in other words, it is 80% of the volume of statue A. So in terms of their volume, they are either in the ratio of 5 to 4 or 1 to 0.8, 0.8 being the decimal of 80%. Now, this means that if those are the ratios of the volumes, the ratios of the lengths will be to the cube root of 1 to the cube root of 0.8. And the cube root of 1, of course, is 1, and the cube root of 0.8 is 0.928. So the surface area will always, the ratio of the surface areas will always be given by the ratio of the lengths squared. So I'm going to square the 1, and I'm going to square the 0.928. And 1 squared, of course, is 1. And this turns out to be 0.8617. So in other words, the surface area of shape B is 86% of the surface area of A. But it says the surface area of statue B is k% less than the surface area. So I need to do 1 minus my 0.8617, and that gives me 0.1382. And so that is 13.8%. smaller than the surface area of statue A. And the question said 3 significant figures, and I have done that. So 2 similar solids, A and B, and we've given some information about them. Now the key information we're given here is about the surface area. So the surface area of A is 7776 and B is 486. So if I divide both sides by 486, it happens that this is 16, which is lovely because that is 4 squared and this is 1 squared. So it means that the surface area of A, the big shape, is 16 times that of B. This means that the lengths will be equal to the square roots of those. And so the ratio of the lengths will be 4 to 1. And the volumes will be in the ratio of 4 cubed to 1 cubed or 1 to 64. The volume of A, the big shape, will be 64 times the volume of the little shape. And this is where we need to go next, because the volume of A is 8 to the power of x, and we know that that is now 64 times the volume of B, which is 2 times 2 to the power of x plus 1. Now, here I'm going to need to find out what x is. So in order to solve this equation, I'm looking at this and thinking 8, 64, and 2 are all powers of 2. So this is 2 cubed to the power of x, and 64 is 2 to the power of 6, 2, 4, 8, 16, 32, 64, times 2 to the power of x plus 1. The 1, sorry, should be a 4, just misread it off here. So here, this gives me, on this side, 2 to the power of 3x, the 3 and the x are multiplied together, and when you multiply powers of the same base, you add the powers together, so this gives me x plus 10. So I've got 10 to the 3x, sorry, 2 to the 3x and 2 to the x plus 10, so the 3x, the 2 powers, must be the same. So if you take x from both sides, you will get that 2x is equal to 10 and x is equal to 5. Now what that means is that the height of shape A is going to be 3 to the power of 5. 3 to the power of x, and x is 5, and that is 243. The height of B, well, we've said here that the lengths are in the ratio of 1 to 4. So the height of B is going to be a quarter of the height of A. So 243 divided by 4 is going to give me the height of solid B, and it wants it as a decimal, and as a decimal it's 60.75. So here we have 2 similar vases, and we're told the ratio or fraction of the surface area of vase B is 25 over 64 times the surface area of vase A. So 25 and 64 are both square numbers, which is going to be very useful. So I've got vase A and vase B, and they are in the ratio of 64 to 25. So vase A is the big one with the 64, and B the small one with 25. And these are square numbers, 8 squared and 5 squared. Now what that means is every length on the vases are going to be in the ratio of the square root of 64 to the square root of 25, which is 8 to 5. And we are interested in this question in their volumes, and the volumes then will be in the ratio of the lengths cubed. And so we'll have 8 cubed to 5 cubed. Now 8 cubed is 512 and 5 cubed is 125. We're then told in this line here that the difference in the volumes is 541.8. Now the difference in these ratios here is 387. So 387 parts or bits of the ratio corresponds to the 581. So 387 bits of volume is 541.8. So if I divide both sides of this by 387, I would find that one part of the volume is 1.4. And I want the volume of vase B. Vase B is the smaller one. Vase B is 125. So if I now multiply both sides of this by 125, I get 125 times 1.4, which is 175, which is the answer. So here we have a circle theorems question. ABCD points on a circle, TDV is a tangent, AB and AD are equal, ABT is 71. Now the important thing with these questions is that you must give a reason for your working at each stage. So the answer alone is not going to score you full marks. So often in questions, it helps to add in an extra line. So I'm going to add in this line from B to D. Because when I add in this line from B to D, the 71 then has this by the alternate segment theorem. So I would need to write that angle ABD is equal to 71 degrees, and I would need to state that it is by the alternate segment theorem. Now, if ABD is 71, then ADB is also 71 because triangle ABD is isosceles. And so the two angles opposite the sides that are the same length are going to be equal. In triangle ABD, angle BAD over on the left-hand side is going to be equal to 38 because 71 and 71 add up to 142 and 142 needs 38 more to complete the angle sum. So this is for the angle sum in triangle ABD. And then the angle that we're trying to get to, which is this one over here, is, well, ABCD is a cyclic quadrilateral. And so because it's a cyclic quadrilateral, the opposite angles add to 180. And so the opposite angle, which we're trying to find, BCD, shown in green, is going to be 180 minus 38, which is 142. So I've got to prove that if angle BCQ, which is marked as X, then angle CDA over here is equal to 2x. And again, I've got to show my working at every stage. So the first thing I'm going to do is draw in the line from A to C. Now this means that by the alternate segment theorem, this angle here is x. So angle CAB is equal to x degrees by the alternate segment theorem. And you do need to state that rule as you're working. Then angle ACB is also x degrees because triangle ABC is isosceles. And so this angle in here will be x degrees because they're opposite the two sides that are marked the same length. I've gone over those here. Those are the two sides that are the same length. And then angle CBA in here is equal to 180 minus x, which is 180 minus 2x. And that's to complete the angle sum in triangle ABC. Now, ABCD is a cyclic quadrilateral. Its four corners lie on the circumference of the same circle. And so the opposite angle, quadrilateral rule, so opposite angles add to 180. And so the angle that we're after, CDA, is going to be 180 minus 180 minus 2x. And so that's 180 minus 180, which is nothing. And minus 2x is plus 2x, which is what we wanted. And we have shown our working at each stage. Here we have a question about intersecting chords. So we have two chords, AB and DC, that have been extended to meet and cross each other at P outside of the circle. Now, providing the chords are A, B, and C, D, it doesn't matter whether they cross inside or outside of the circle. The rule that the distance from P to A times P to B will be equal to P to C times P to D applies irrespective of where they cross. So, got to be a little bit careful here. P to A is not 16, P to A is 30. P to B is 14, P to C is 12, and P to D is what we're going to be after, because we're trying to work out DC. So firstly, we're going to have to work out what PD is. So PD is going to be equal to 30 times 14 all over 12, and that drops out very nicely to be 35. So the distance from P to D is 35. This takes up 12 of it. So what we want, which is the length of DC, DC is going to be equal to 35 minus 12, which is 23 centimeters, and that's your answer. This is a great question because it's slightly different on the topic of proportion. So if we start off in the normal way, Q is directly proportional to the square root of t, so Q is equal to K times the square root of t. Now, normally what happens in a question is they tell you when t equals this number, Q is equal to that number, but they haven't done that this time. They're giving you a graph. So you need to pick a pair of values off the graph. Now, I'm going to choose this point here because it gives me nice integer solutions. T is equal to 4, Q is equal to 6. So when T is equal to 4, Q is equal to 6. And so I'm going to use those values to find K. So Q is equal to 6 when T is equal to 4. Square root of 4 is 2, K must be equal to 3, and your rule for Q in terms of T is that Q is equal to 3 times the square root of T. But a nice question, slightly different in getting this pair of values out of the graph. You're then told that Q is increased by 20%. Now, slightly difficult to explain this one, but basically, if this goes up by 20%, it's going to go up and be multiplied by 1.2. The 3 is going to stay fixed, so that this square root of t must increase by 20%. But what will happen is it's going to be inside the square root. So you're going to need to have 1.2 squared inside the square root to make it increase by 20%. 1.2 times 1.2 is 1.44, and that's a 44% increase. Now, that's a little bit awkward, but there is another way that you could tackle this. You were told that when Q was equal to 6, when T was equal to 4. So if you increase this by 20%, you would multiply it by 1.2. And if you multiply it by 1.2, you'd get 7.2. So your equation now would be 7.2q is equal to 3 times the square root of t. If you divide both sides by 3, you will get the square root of t. And when you divide both sides by 3, that's the square root of t is 2.4. So when you square both sides here, t becomes equal to 5.76. So when Q is 7.2, T is 5.76. So T has gone from 4 up to 5.6. In other words, it has increased by 1.76 from 4 to 5.76. It has increased by 1.76 from the number 4. And to convert that into a percentage, you multiply it by 100, and that gives you 44%. So there are different ways you could tackle that question. So a proportional question, but slightly unusually, we have two proportions linked here. So we have that y is inversely proportional to the square root of x, and x is proportional or directly proportional to t cubed. Now, when you come to write this, you can replace x by t cubed. So you can say that y is proportional to 1 over t cubed, square rooted. And so y is going to be equal to k over t cubed here. That 3 up here should be a power. So we can now use that when y is equal to 8, t is equal to 25. So I'm going to use these values to find k. So y is equal to 8 when t is equal to 25. So I'm going to take the 25 and cube it and square root it. And so k turns out to be 8 times 25 cubed square rooted, and that very nicely turns out to be 1,000. So my rule is now y equals 1,000 over the square root of t cubed. So I now need to find out what t is when y is 27. So I'm going to replace the 27 here by the square root of t cubed. Now the question does say it wants the exact value. So we will need to make sure that we do that. So if I multiply both sides by the square root of t cubed and divide both sides by 27, I get to here. Now if I square both sides, I will get t squared is equal to 1,000 squared, which is 1,000,000, over 27 squared. And so t will be equal to the cube root of that, 1,000,000 over 27 squared. And your calculator will tell you that that's 100 over 9. And it does want it as an exact value, so don't write that as a decimal. So we're told that the area of this rectangle is less than 75. So if I take the length, 2x plus 3, and multiply it by the height, x minus 1, I must get less than 75. So I'm going to expand the brackets on the right-hand side. 2x squared plus 3x minus 2x is plus x. Take away 3 is less than 75. I'm going to subtract the 75 from both sides to make it less than 0, because with a quadratic equation or an equation, you want 0 on the other side. Now, slightly awkward to factorize, but 6 times 13 is 78. So if you factorize this, it will factorize with 2x and x. And if we make this plus 13 and minus 6, then this loop would give me plus 13x, and this would give me minus 12x, which is going to leave me with the plus x that I want in here, and so less than 0. So you find your two critical values. So your two critical values are when 2x plus 13 is equal to 0, 2x is equal to 13, x is equal to 13 on 2, minus 13 on 2, and x minus 6 is equal to 0, which happens when x is equal to 6. So the solutions to this inequality with no context whatsoever are that you need to be between minus 13 on 2, so minus 6.5, and 6. Now, there's two little tricks here. Firstly, x is a value that is a length, and you can't have negative lengths. So this minus is going to cause an issue. But a little bit more than that. This here, x minus 1, is a length, and so x minus 1 must be positive. If it's not positive, then the height of the rectangle isn't positive. It's either 0 or negative, and we have a problem. So x, for the question to make sense, needs to be bigger than 1. So we need to put this in here and change this to be that x has to be between 1 and 6. So that's a really tricky bit there to realise that minus 13 on 2 and the negative values, and indeed the positive values up to 1, would not work in this instance. So check that your answers make sense in the context of the question. Here we have a quadratic inequality. So 6x squared plus 37x is less than or equal to 35. Now, when you're solving a quadratic equation or inequation, you want it equal to 0. So I'm going to subtract the 35 from both sides. Now, I'm rather hoping that this is going to factorise. Now, if it does factorise, it will either factorise with an x and a 6x or a 3x and a 2x. But thankfully, 35 is prime, so it must be 7 and 5. So if I put the 7 here and the 5, this will give me 5x, and this 7 and 6 will give me 42x. So if I make it plus 42x minus 5x, I will have the 37x. So my two critical values are either that x is equal to 5 over 6, adding 5 and dividing by 6, or x plus 7 is 0 when x is equal to minus 7. Now, because it's a quadratic inequality and it needs to be less than 0, I need to be in between these values, and so my values of x must be greater than or equal to minus 7 and less than or equal to 5/6. And you should write it like this as a single inequality. So ABCD is a trapezium and AB is parallel to DC. So we're given some points. So I always think it's best to have a little sketch so that I can see what's going on. So the point A has coordinates of minus 4 and 6, and so is going to be in here somewhere. The point B has coordinates 2, 3, so 2, 3 is going to be in here somewhere. The point D has coordinates minus 1, 8, and so is going to be up here somewhere. Now, this is a trapezium, and we're told that it has only one line of symmetry. And we're told that AB is parallel to DC. So AB is here, DC must be in here somewhere. And so point C is going to be in here, and we're going to have a trapezium that's going to have one line of symmetry. And so its line of symmetry is probably going to come through here somehow, and is going to go through the midpoint of AB, and it will go through the midpoint of DC. So what we're going to need to do is we're going to need to find, in effect, the perpendicular bisector of the line AB. And we've seen this type of question many times in different contexts. So here, the gradient of AB is the rise over the run. And this had a B had an a y coordinate of 3, A of 6, so it's 6 minus 3, and the y coordinates, and the minus 4 minus 2, and so we end up with minus 3 over 6. The gradient of AB is minus a half. Now the midpoint of AB, which I'll label on here as M, so M is going to be equal to the average of the x coordinates. So minus 4 plus 2, and the average of the y coordinates, 6 plus 3 on 2. And so this has coordinates of minus 1, 4.5. So I don't need to know the equation of the line AB. What I do want to know is the equation of the green line. So the green line, the green line is going to be perpendicular to AB. So the green line is going to have a gradient of 2. So this point here is the point E, which is what we're going to try and work out in a minute. So the gradient of M to E is going to be the negative reciprocal of a half, which is 2, which means it's going to be y equals 2x plus something. And we know that this line has to go through the point M. So when y is equal to 4.5, when x is equal to -1, and this tells me that c is 6.5. So the equation of the green line is y equals 2x plus 6.5. Now, E is a point on that line. Now, E is also a point on this line shown in red. So the red line is the line that goes through D and C, but will also go through E. Now, this line is parallel to AB. So this line is parallel to AB. So the red line is going to have an equation of y equals -1/2x plus something, because it's parallel to AB, which has a gradient of -1/2. But this red line needs to go through D, and D has coordinates -1, 8. So 8 here is the y coordinate when x is equal to -1. And so if this is +1/2, we take the half from here, c is equal to 7.5. So the equation of the red line is y equals -1/2x plus 7.5. Now, what the question wants us to do is to find the coordinates of point E. Now, E is on the green line. E is on 2x plus 6. Y equals 2x plus 6.5. E is on the red line. Y equals -1/2x plus 7.5. So I can put these two together and solve them simultaneously and say that 2x plus 6.5 is equal to -1/2x plus 7.5. And if I add half an x to both sides, I would get 2.5x. If I take the 6.5 away from both sides, I get to 1, and I find that x is equal to 2/5. If x is equal to 2/5, y is equal to 7.3, and so the final answer, which I'll write in up here, is that x is equal to 2/5 and y is equal to 7.3. If you use fractions for both, decimals for both, or a mixture, that is fine. So we needed the perpendicular bisector of AB, we needed the line of DC, we needed to solve them simultaneously to find the coordinates of E. So a probability question: bag contains only 10-cent coins and 20-cent coins. Joseph's taking a coin at random, records its value, and replaces it in the bag. He then takes a second coin and replaces it in the bag. He finds the mean of the two coins. The probability that the two coins have a mean of 10 is 49 on 21. Now, the only way you can have with two coins is to have a mean of 10 is to get 10 and then another 10. So the probability that you get a 10 and then another 10 is going to be equal to 49 on 121. Now, because the coins are replaced, the probability of a 10 is going to be constant. So 49 and 121 are both square numbers. They are 7 squared and 11 squared. And so the probability of getting a 10 is going to be 7 out of 11. That therefore means that because there's only 10 or 20-cent coins in the bag, that the probability of a 20-cent coin is 4 out of 11. Notice it doesn't mean that there are 11 coins in the bag. There could be 22, for instance, but those are probabilities. If you want to have a mean of 15, you need to get a total of 30. And to get a total of 30, you either need to get a 10 and then a 20, or a 20 and then a 10. So you've got to make sure that you double this up. So the probability of a 10 is 7 out of 11. The probability of a 20 is 4 out of 11, but you can do that either way round. And so you need to multiply it by 2, and that gives you 56 on 121. So a probability question. It's from a little bit earlier in the paper, so it might not be quite grade 9. But in a bag, there are only red, blue, green, and yellow counters. The number of The total number of counters in the bag is 80, and the number of red counters is x plus 7. And we're told the probability of red is a quarter. So the probability that we pick a red one is a quarter, but a quarter must be equal to the number of red counters out of 80, and a quarter is equal to 20 out of 80, and so x must be 13. So because x is equal to 13, the number of red counters will be x plus 7, which is 20. The number of blue counters will be x minus 11. 13 minus 11 is 2. The number of green counters will be 3x. 3 x's, or 3 13s, sorry, are 39. The number of yellow counters will be what is needed to complete the full bag of 80. And 80, take away 39, take away 20, take away 2 is equal to 19. And so the number of yellow counters is 19, and the probability that you pick a yellow counter is 19 out of 80. 19 is a prime number, it won't simplify.
Very well done for making it through those 17 really quite feisty questions, and a big thank you to Mr. Neer for putting the film together and allowing me to share it with all of you on the channel. Please do leave a comment, leave a question if there's anything that's unclear, or tell us how you've got on with the questions. And please do take a moment to thank Mr. Neer too for allowing me to share the film with all of you. And we really hope you found it useful and it stands you in good stead for your exams next week. If you know anybody else who's also going for that top grade, please do share the film with them, and I'm sure they too will find it useful. Okay, see you in the next film.